Hello, everybody. So I'm so glad to be here. And Ned, I miss you so much. Oh, okay, right now I'm appearing right now. I miss you all from the HashConf. It was amazing. It was an amazing experience last year. And I was joking with Alexandra that I'm from Rio de Janeiro. I was born in São Paulo, but actually I live in Rio, and things in Brazil just start later the carnival. So we are going to start the meetups and everything that we have on here in Rio with the HashiCorp just right now because carnival is over, the parties are over. So okay, let's go. And I'm starting the community things. Just one day later the carnival. So we are just like still a little bit tired, but we have a lot of things. So today I'm going to present about on how in the company that I work that it's on Storyblok. Um, we work it in a journey about security, implementing and Terraform, in a journey about also infrastructure as code, to make us start using containers. And so we had an experience with Elastic Beanstalk and VMs, and we had like just one person working with DevOps, and later we wanted to change everything. And later that the way that we wanted to start to use more DevOps, and not only the culture but also the frameworks and the tools that it has, it was starting using containers. I think the better way to we start using and implementing the DevOps culture is using the containers. And so we started that with Docker and with Terraform, and of course with cloud to make us through this better way. So just a little bit about me. I'm Camila Martins. The pronouns you can use she, they, whatever you want. I'm a senior site reliability engineer in Storyblok since 2021, and I'm a HashiCorp ambassador. I also coordinating the events here and the meetups here in Rio de Janeiro, Brazil. And in HashConf, the last HashConf, I was also a Terraform certified associate, and I was so happy. And if you want to watch me in the social media, you can find me with Punk Do DevOps. It's crazy because Punk do DevOps. I know that in English it's something wrong grammatically with like Punk does DevOps, but in Brazil it's like Punk from DevOps. So maybe it's something strange, but it's like that. So introduction. So why we started to migrate that? So it was because Beanstalk. First, because we wanted to use more DevOps frameworks and tools and whatever, like I said before, and also because Beanstalk is already degrading in AWS, so we wanted something that it's more new. So we started to think about how we could do that, and how we work it before. So we had the Elastic Beanstalk with our applications, and it works in Ruby. So our backend is in Ruby. And we deploy that with code build and code pipeline that honestly, I think it's not the best way, like actually. But we did that. And it's because when it's in virtual machines, we had a lot of problems with lazy deploy. So sometimes it takes too much to make a deploy happen. And also, the developers do not have a visibility what's going on. So sometimes when it goes through an error or something like that, it takes too much to make a deploy happen because it's a virtual machine. And later, when it happens, we take such a time to discover when something's going wrong. Even when we have some observability tools, like for example, Sentry, whatever, Graylog, I don't know, log Steam applications. And we want in a way that developers can be closer to the DevOps team and even help us and even change the code with us. That's the way that we want it. So, and like I said, developers need to check environment with DevOps. So the way that we work it before, it was something like, okay, I'm going to deploy that to you, and later when it's done, I'm going to say to you if it's good or not. And we wanted the developers to know what's going on. And because of some security things, we did that so much away from them, so they do not see a lot of things. So we started to change that because our group, our team in DevOps, it started to grow. So we have more people and more time to do that. And also, even it's in Ruby, we had some problems with memory and heap space, and to deal with the instance type of the machines in AWS. So we wanted a way to scale it better and scale it with not that much cost. So when we use containers and use it in a right way, we do not we do not have that much cost. And we can scale more and scale better and think better on that. We were doing tests in Fargate, and also we were doing tests in EC2. And well, Fargate, I know that it performs better, and we have a demand on the performance and when the requests are entering on the server, but it takes more costs. But actually, we use the applications more in EC2, and some is specific things we use Fargate when we want something to go faster, or some things we have a lot of requests and we need a response faster about from our servers. And it was something like that way. So we had the code pipeline and, well, the things that go with that. So the code commit that takes the files and make the changes, and the code pipeline and the code deploy. And it was later going to an Elastic Beanstalk. Actually, this image shows an ECS, but our visibility and our design was made to Elastic Beanstalk. And a lot of things we also maintain in an S3. So it was that way. So we started to make it slowly. So making a little changes. So for example, we started to moving slowly to Docker, and moving slowly some specific applications to check how is it going to be the behavior of it. So, well, it was like what we had before. So the code pipeline and the deploy, and we got the images that we wanted, and we put it in a Beanstalk. But later that, like I said, we did something step by step, like baby steps. So we started running Docker locally with the applications that we have. So for example, if we have some running in a virtual machine, we just downloaded a clone the application, and we started to create a Docker file in our own machine, in our desktop. And we started to create a Docker file, a Docker image, and run it locally to check if it runs fine. And later that, we started to deploy in a common EC2. And if it was working fine, we started to create task definitions and, well, the JSON for that. And but all of these files, we started to create like a design that it has like a standard, and this standard was all created with Terraform. So the standard for the services, for the cluster, for the task definition, like modules, we created modules that we call a Terraform catalog. for everything that we have. So, for example, there is a standard for creating cluster, for creating services, for creating task definitions, for creating load balancers. So, if I want to create something in my cloud, I have already a way to create it. And well, I'm not exactly here to say that Terraform is so good and you can use that, but really Terraform is so good because when we were in a test time, if something was wrong, going wrong, we just deleted that. And we didn't have problems about cost or about forgetting something in the infrastructure. So for POC, it's so good because we don't have problem about, for example, creating some resource manually, and later we have problems with that and forgetting and the costs, and or later, I don't know, having problems to creating another one, and maybe it's the same name, and well, we have trouble. Well, so Terraform creates a standard, and we needed that because we wanted to create a lot of resources in different accounts and in different regions. So it was really good because even, for example, in IAM, things that it's so boring to create manually, Terraform helps a lot, and helps a lot also about security because you know exactly how create policies, how create the roles, how create the users. And it happens later when you're going to automatize the security steps, like I'm going to say in the future here in the talk about tfsec, postee, and another aquasec tools that we use to check our vulnerabilities on Terraform code. And like I said, later we create the task definition, and we started to set. It was something that we decided in our project because people decided that way. But later, obviously, we changed it. But we had like one machine per service. Later, when we were more confident about our resources and more confident about what we created, we started to scale it. So, for example, we have one big machine, and we have, for example, 20 containers inside, 30 containers inside, for example, and not obviously one container per machine because it doesn't make sense. Well, and of course, we started to open this world to the developers because that's what we wanted. DevOps is that. So we started to make the developers make part of it. So we started to talk more even about, oh, this is an infrastructure as code, you can change like that. And well, this is a Docker file. Do you know what's a Docker file? Do you know what is an HCL? Do you know what's Terraform? And it's easy, you can just change it and change that. And so they started to embrace that. And it was really interesting because they started to update their own Docker files and even make some changes in the Terraform codes. So it makes our DevOps team more less things to do. And not exactly, we have a lot of things to do still, but like they are more confident, and they are they have more independence to do the things. And we have the images still, some images in ECR, but some images we started to deploy in Harbor. And we started to create more monitoring services, not just in AWS, because AWS, they do not have access, but we started to create more observability to devs. So we started to create like more chat ops and Grafana and whatever, things that help them a lot. And it's not like a thing, hey, what's about to deploy? It already ended or not? And no, they already know when it ends or not because we started to integrate everything. And for such a time, we just maintained the code pipeline. But actually, I'm going to talk more about this. Now we are actually using GitHub Actions because, well, it's more close to them because they are always using the GitHub, and they already understand how it works, because we already works a lot with the GitHub actions and the GitHub pipelines. So they understand how the troubleshooting works. So it's more, and they can, like I said before, they can watch everything that's going on. So this is a part, like I said, we did babe steps. So it's a part, we have like a GitHub repository, and we maintain it for a time, the code pipeline, and we started to go through the ECS and the ECR, and we have some things in Harbor. CloudFormation, we do not work. We actually work full with Terraform, because we do not know exactly if you're going to work with multi-cloud, and because, well, Terraform operates so much better, but nobody needs to know. But well, whatever. Everybody needs to know that Terraform works so much better. The way to code and the way to troubleshoot so much better. I'm sorry, the West, but well, actually, it's true. So well, later that in the future, what we did, like we are watching it, we did the Docker thing, and also implemented the Terraform, and later what we have actually no, because we are in the final process of the migration, so we still do not have some things migrated. We just have like 2 or 3 servers still in Beanstalk, but we already migrated everything that, I don't know, it's maybe we had like more than 10 or 15 servers, and now we have like just 2 or 3 that we still work in Beanstalk, and we are going to migrate like next week. So it's really going through. It's really good. So nice. I can't wait to just work with containers, because we have a lot of plans with that. So well, we move it, like I said, everything to GitHub Actions, because we already know how to use it, the developers. And also we have a visibility, they have a visibility, and they can watch every deploy process. They can change, like, for example, they can change the GitHub Actions IML. They can change, well, even the GitHub, the Terraform process, because some developers are more with a more senior level already can do that, and they just ask us like, oh, can we do that? But it's a thing that we thinking about DevOps, we do not have a bureaucracy. So it's just, okay, let's go. We are a team. So, and we started to implement some security tools and validating steps with our Terraform code. So now that we have a Terraform catalog completed, so everything that we wanted to deploy in the AWS, we started to think about how we are going to validate that, because sometimes we are going to change the catalog or change some things, and other developers are going to change. And how we can know that everything's working fine and our CVE it's fine, and we do not have trouble about things that when we were building that Terraform catalog, we just watch it that we have a lot of problems and, well, security issues with ALB and security groups and IAM and, well, policies. So it's a thing that we need to take care of. For example, if I have an S3, we need to encrypt that. And it's a thing that some AquaSec tools can tell you how to do. It's interesting because they tell you the CVE and also how to check, how to fix that. So, well, we did 3 things. The first one is that we have now implemented the postee, that it's an API that route messages. And for us, we did like a chat ops. So what it does is that when it creates with the tfsec a CVE, it goes to a Jira board that it's just for us about DevSecOps. So we know everything that is still going wrong with vulnerabilities. And just a regard that we also use in our Visual Code an extension from Sneak that it's also to check some vulnerabilities in the code, but I don't remember exactly if they can get something from Terraform, or they can get some things about JavaScript and Python also. And so we always have this kind of extensions in the Visual Code just to check if you're doing things right. But about Terraform, the CVE, it's just fine to us just to know and open a Jira card and it already puts in backlog just to know if something's going wrong, and to DevOps team investigate by cybersecurity team side. And we implemented that through the pipeline. So we do not have, for example, the problem that, oh, we need to check that. Oh, we forgot that. And we cannot mute the information like, oh, I'm going to ignore that because it's not that trouble. Like, no, you're not going to ignore that. It's important because, well, like some tips that I'm going to talk in the future of this talk. Well, need to always get the things updated because, well, we already know some famous trouble that we have that it goes because we do not have the things updated. We do not have the applications updated, the libraries from this programming languages updated, and things like that. So we need to get the things updated. And well, about the tfsec, checking security in code, like I said, through the GitHub action pipeline, we check the vulnerabilities in the Terraform code. So it's good because it's always telling us where are the vulnerabilities and what we need to do. And so mostly about ALB, IAM, security groups that has have the ports and too much open it, like everything open it to internet like, and or everyone can access 22, so whatever. And a lot of things also, like I said, about encrypting with KMS, so it's important also. Some things we need to put in secret manager, so it's always remembering you what you need to do. And and when you get the CVE, it shows you the error of the vulnerability and also documentation of what you need to do. So it's so easy to fix. It's so good. The documentation, it's really good. And we use on Terraform. So validating the code in steps. So we use the Terraform validate to validate the config files, the things that we have by ourselves, and also Terraform format because, well, we have not a lot of people, but we have some people working on their repositories. So when we are going to put that on AWS or whatever the cloud that we want, we need to know if the consistency is fine. So that's a way. So we put it in one of the pipeline steps. So about validating, formatting the code, and putting the tfsec, and also posting it with the postee to our Jira if something is still going wrong with the CVE, or for example, someone created a new resource and it has some trouble with well, security, like create a new security group and it's open it to a port that it doesn't, I can't open to the port or whatever. Well, and the sec tips that I can say, and in general, it's that we use also the sensitive true in Terraform code because we do not want to output something that is sensitive in the std out. And the roles, it's a thing that I really like the most because it makes our work better. That it's about creating the roles and the policies and the users and whatever about IAM with Terraform. Because when you're going to do that manually, the first it's that it's really bad. It's really lazy. It's boring. It's just like, oh, I'm going to roles and I'm going to and I get some error in the JSON and formatting. So well, Terraform, it's really fast to that, and you recreate a standard, like I said before. And well, so later that it's good also because when everything it's down the Terraform, it's inside the Terraform, I can know if something is wrong with the security. Even that part, from the roles, that it's one of the most important things. So if I put everything in Terraform code, well, CV is ready to know if I did something wrong with that policies. For example, I put some role to every resources, some well some rule to every resources in AWS. So I can get files from every S3 buckets. I do not want that. I just want from next specific S3. So it makes me know if I did something wrong in that way, or maybe full access to some user that I can do that. And so CV from the tfsec makes me sure that I didn't do something in that way. Passwords information in secret manager, in our case in AWS, but we can do also in Vault, for example. But in our case, we did in secret manager, and we can also integrate Vault with secret manager or whatever. The security groups I said before, only with the needed ports. It's a thing that also the CVE talks about. So if I have a rule that it's to open it, the tfsec is going to tell me that backend files in S3 and encrypted with KMS. It's a thing that we do because it's too important for our state file to, well, if something got wrong, or if we lost the file or whatever, and or if it corrupted the file, we have it in a cloud. Version it. It's a thing that also the tfsec asks you that the S3 bucket has the files version it. So it's a thing that it's good because we do not lose data, and it's also a security thing. It's so important too. Rotating keys, we can already do that through Terraform and also with the KMS. And not storing, of course, secrets in code, hard coded, or in state file, because even you're going to put that in an S3 encrypted, well, someone can get that. And take care about using models. If you're going to construct the model, well, it's one thing, but if you're going to get a model for someone, it's an owner that we can trust. It's something officially from HashiCorp, or you're just, because it's not because everybody use that or it's too downloaded. It's a thing that we can trust. So we need to take care. Where are we using the things from which place we are using that thing? So and not just from models. We are talking also about Docker images and, well, whatever libraries that we are putting in our programming languages. Well, and keep everything updated. So, well, if you have a release from Terraform, if you have a release from Aquasec tools, update that, because it has new information from new vulnerabilities that it's now on market, on, well, through the technology. And also, well, Terraform, it's always making it better to, well, uncover more things, uncover more usabilities for us, and automate the security and code validation steps in pipeline to check if something is out of the way. Because, well, it's not every day that we are going to remember that. And it's dangerous. So DevOps is about that. DevOps is about provisioning. It's about automatizing things. So it's a way that put the things out of our hand, the most that where we can do. So, well, the security and the code validation is too important to put in the pipelines, because you do not know what's going to happen tomorrow. Like, for example, the log4j, it was a surprise for a lot of people. So we do not want surprises, because, for example, talking about security, it's too sensitive to, well, be surprised. Maybe it's too late. So be always updated to, well, know what's going on in your infrastructure, and to take care before someone does it to you. And maybe it's not to be a good thing. So, well, the general things that I can say to you, it's that automatize your security steps, not only in Terraform, but in everything through the cloud. And make people take care about it, not only the DevOps team or the security, because the security, cyber security team. Because when we think about security, we think that, oh, DevOps is going to take care because of the DevSec ops things and whatever, or cybersecurity because they are cybersecurity, but not security is a responsibility from everyone. So even from them, so that's why DevOps culture helps us, because it helps with feedback, tech feedback, and also constructive skills, soft and hard skills feedback. So talk with the teams, do a cross platform job, from what's going on. Do you know this platform, this tool more, that brings more security for us, because it's going to help everyone to do not be surprised with something that certainly got wrong. So validate your code and, well, organize problems and vulnerabilities in Kanban or sprints. That's a thing that we do, for example, in AWS. And I know that other clouds do that also. We have, like, for example, a board, like Security Hub in AWS, but I know Azure has it also, and GCP too, that we can check what's the vulnerabilities that actually we have in the resources in the cloud, and what's the level of prioritizing that. It's high or not, whatever, and how to deal with that. It also has a lot of documentations attached, and it can help a lot. And create a migration script, it's also too good, because when you're going to migrate something, you need to do baby steps, but also you need to think about, if everything's going wrong, how can I roll back that? So we did something about that. But when you're going to, when we do baby steps, it's good, because if you're going slowly, you know how to change it back. So not going to migrating fast and, oh my god, everything's going wrong, so how can we do right now? So we did it like slowly, but with more confident, and that everything was going really fine. And check everything close to the dev team. I already said that a lot of times, and it's a thing that we need to create a culture, so we need to talk with them. And even Storyblok, it's a company that everyone is remotely, so we have people from, well, every country in the world. But so it's a way that we are always talking. We are always talking with each other, through the meets that we have, through async or not async. We are always talking. So it's good, because we are always embracing talking and always doing the feedback. So maybe that's why the things go through easily. And observability is good, and it's not because, oh, observability is a hype. No, observability is good, of course, because it helps our team, our DevOps team. So if something is going wrong, we know it faster and we can act faster on it. But also the dev team can know what's going wrong, can help us, and can understand more how infrastructure works. And so I think that's it by my side. That's my GitHub, that's my personal website, my LinkedIn. And for who wants to know more, how and what we do in the Rio de Janeiro HashiCorp user group, that's the link. We are going to do a Terraform 101 in the next week, because, like I said, things just start in Brazil later, the carnival. And that's it.